StereoKit is an open source mixed reality library for C# developers. It's really good for building applications and tools. Instead of focusing on the games and interactive media use case, it focuses on applications and productivity and things like that. So it focuses very much on like how do I do these real world problems that applications need to solve, like loading files from the file system using a built-in file picker makes it really easy. And in general, it just makes the mixed reality development experience much easier. So it is basically an entire engine of its own. It's an alternative to the other tools that are out there, but it is very specifically focused on mixed reality first. So all of the defaults are set up to work really well in mixed reality. All the graphics are tuned to work really well on mobile mixed reality headsets. And it's just a really good experience for those of you who are developing applications that are specifically for mixed reality. It's also a part of the C# ecosystem, just using the regular C# stuff. So nothing fancy or funky going on here. You can just work with NuGet and the latest and greatest .NET features. So it's really good for developers who are already in the .NET ecosystem and really want to make the most of it.
Hello and welcome. Hi,
everyone. Welcome to our first globalxr talks this year in 2023. And it's going to be a really cool one.
About the Industrial Metaverse with Tom Wisniewski and Jim Bennett of Microsoft. I'm very excited for today's speakers.
Yeah, me too. This is one of the subjects which is very interesting. And it's actually part of most of my work. So I'm going to really enjoy today. But before we start with the sessions, first something else. So,
the news.
Back to the news. Yeah, we are trying some new stuff out with some new cool videos in between. So hopefully you're going to like it.
We're going to start with a short section about the latest news in XR.
Yes.
Alexander, do you want to start?
Shall we start with one? So the first one is about MetaQuest V5 update. I love that
50.
one. Sorry?
50. It's 50, right?
50, apologies. 50, you're right. It's not the 5th, the 50th. And it's really interesting. I do a lot with when we do OpenXR projects, also for virtual reality. We use mostly the Quest 2 and the Pro. And there are some really cool things going on with the new updates. And one of the things is the in-game multitasking. Now, this is something which was actually already available in the Pro, but it's going to be available also in the Quest 2. And I still have to get used to it. Maybe it's my age, but the idea is multitasking when you're gaming. And to be honest, I have since a week also a PlayStation where this is actually something very normal to do.
That's another news item.
Yeah, that's another news item we'll get back to. But it means that you can actually have like a walkthrough next to playing a game, but it allows you to have something else open. And
2D though, right? So you can have you're in your 3D game or whatever. You're hanging out. You have to wait for something before your next game starts, for example, and then you can open another 2D application, like browse, or if you're stuck in your game, like have a look at a YouTube walkthrough, that kind of stuff.
Yeah.
right?
I think for me it would be too much information overall, but yeah, I see some advantages of that one. The other one is direct touch, and this is really interesting
Yes,
because
like
hand movement,
HoloLens.
yeah, hand movement was already possible with Oculus, but always with pinch, and now which is actually HoloLens 1. And now with the new version, we have the ability just to use your
Touch.
fingers. Just you get like HoloLens 2 capabilities on Oculus Quest, which is actually cool. And the last
Very
one,
cool.
yeah, I love that one specifically because and the last one is also an interesting one. I have a Pro for a few weeks already because of some of the projects I'm doing. And one of the biggest things I found as a challenge is that it always takes a bit of time before it notices the controllers, because the controllers, they have their own tracking, and for some reason it takes a bit longer. With the new version, with this version, there's an update which makes it so that when you pick up the controllers, it will directly recognize them and understand that it needs to move away from the hands, which was in the current version, the previous version, not working so well. So I'm really glad with this one. So that was
really
about,
much faster now. Yeah, that was the update on MetaQuest number 50.
Yes.
Let's go to another item. Big Screen VR. I think that was a really cool news. Big Screen VR, maker of the Big Screen app that people use to, watch YouTube or watch other streaming services. In the headset, they came out with their own hardware, right? Big Screen Beyond, which is a super light headset with really good optics. I think it uses same kind of lenses as the Oculus Pro. Resolution is really good, and it's super light. And kind of scan your own face. If you have a new kind of iPhone, you can scan your face, and then they do the kind of the face parts and mold it to your face, which is pretty cool.
Yeah, they make a specific mold of the foam which is placed in the device, which will fit perfectly. And you have insert lenses. So for me as having
because your glasses won't fit anymore.
Yeah, it's not going to fit any glasses.
It's too small. You can't get it over your glasses. So they have lenses, which is cool. But also I read they have fixed IPD, which means you basically cannot share it. It's like a really personalized headset for yourself.
Yeah, it is definitely
kind of difficult to share. But,
so more reason to have it for your own when you're at home.
Exactly, you don't have to give it to your kids anymore. And I think it's kind of you could say kind of a replacement almost for like the headset like the Valve Index, because it works with Steam VR technology. You have the works with Index controllers and Valve controllers, I think, and like the Steam VR tracking.
Yeah. Yeah, the only thing what was not entirely clear to me, but I think it's still, I think you still need a cable connected because it requires some big hardware to run it.
Exactly, it's exactly like the Index basically.
Yeah,
technology-wise, the tracking and and also the price range. I think it's like $1,000 with just the headset without any controllers or base stations. So it's not cheap. But it's really cool.
Yeah, on the other hand, the Pro is around $1,800, and if you buy an HoloLens, it even goes double.
Yeah.
And I don't want to know what Apple's going to cost. I have some ideas.
But if your use case is kind of like the Index, then that's a good alternative.
Especially for the high quality cases, this is really interesting.
Yeah, for sure. So you had something about Blender, right? That you wanted to talk about.
Yeah, that's a really interesting one. I actually came across it, and you have something called Blender GIS, and what it allows you to use GIS data into Blender, which enables you to import any type of GIS data, and if it's being in shapefile or raster image, and you can generate 3D terrain based on the GIS data. So imagine now I can connect to Google or to any other geographical information and then just create through an add-on within Blender. Now, why is this interesting? One, because when you talk about more specifically Industrial Metaverse, it would be interesting to have geo data where you project stuff on. The other thing is Blender is a free product. and which makes with the add-on, which is also free, provided through GitHub. It gives you a lot of tools. So that's really interesting.
Yeah. Oh, someone in the chat is actually asking if we can post links to our news items.
Yes, I will do that.
Which I think is a great idea. We'll do that later.
Yes,
Claudia.
I will do that.
No problem. Yeah. So another news item, Nerf. If any of you have been to SIGGRAPH last year, the paper that won like the best paper award was on instant Nerf creation, where you can basically take a couple of pictures and it will, using like Nerfs, it will create a 3D environment from that. And the news about that is there's now a virtual reality version, so that you can create a VR environment from pictures, which I think is awesome. And NVIDIA, so it's by NVIDIA, and NVIDIA actually has a contest going until, I think, next week, Wednesday, where you can make your own VR environment using Instant Nerf, and then you can win a prize.
Yeah, so, they are challenging everyone to make something really cool, and then, But I like this because it's, to be honest, if you think about, so for me, I'm absolutely not a 3D designer and building immersive tech applications. I always require to have designers to do things, and or you need Sketchfab, TurboSquid, and other platforms to get your content. And this actually allows you not so, really easily actually to generate your own 3D content based on 2D images.
Yeah,
and that is
super fast.
Yeah.
Yes. Using lots of NVIDIA cards, of course, but still super fast.
Shall I just share one other thing?
Of course.
I think I'm gonna
maybe?
No, I think I'm going to make someone happy. I know he will be. So, old friend of mine, I still have a lot of contact with him, Joost van Schuit.
Old friend of both of us, I think.
Both of us, actually. Also goes by the name Local Joost, has on his English, Local Joost, has an app, always had in HoloLens 1, HoloLens 2 app store, which was called Holo etc. And yeah, perfectly, thanks. And it is now also available on Meta Quest, which is really cool. I've been playing around with it. It is really nice. So just try that one out. So I think for that, we have had some really interesting news items.
Yes, and, that's one more thing I want to mention, actually, because I think it's so cool. And it's the Google Cloud streaming platform called Immersive Stream. Immersive Stream for XR is basically, it's a platform where you can, with Unreal Engine, you can build an application and then it runs in the Google Cloud on your headset. And it's also pretty new. So, and there's a tutorial, and also for people like me who don't use Unreal Engine a lot, I'm like a Unity developer. There's a really nice tutorial on how to get started quickly with that. So I recommend people try that.
Yeah, and I think the reason why I think it's also cool is because we already have some parties worldwide who create streaming services. And of course, Microsoft, the same thing with cloud streaming, which is the remote rendering service. It is really cool to see that other bigger tech companies are starting to do the same thing, because at some point, especially when we go to the 5G networks, you want to go to the point that you're not running applications anymore on devices, but you're streaming the applications, which makes the quality of applications way higher than we normally have. So that is actually
without
good
a cable.
Into the future. Yeah,
you can run that on your Meta Quest, and we don't have and you don't need a giant computer and a big cable and everything. It's just so much more user friendly.
Shall I pull Tom Wisniewski in the call?
Yes. So that was the news, and let's say hello to our first speaker.
Hi, Tom.
Hey.
Hi, Tom.
Thanks for having me.
Now, welcome. Can you tell me a bit about yourself and what you're going to present?
So I am one of a few folks that represent our Industrial Metaverse marketing team here at Microsoft. And my responsibilities on the team extend to the go-to-market for our industrial metaverse. So the strategy and sort of enablement and execution of that go-to-market at a global level. And so today I thought, it'd be a good, we're just starting to build sort of our perspective and 100 level deck around the industrial metaverse. So I thought it would be good to, casually go through that with everybody today, pieces of it, not the whole thing, because we don't have enough time for that. So we'll just go through some of the deck, and hopefully it gives everyone on the here perspective in terms of how we, Microsoft, are thinking about the industrial metaverse from a technology and people perspective.
Perfect. So let me pull in your deck. So you mentioned you want us to be here, or?
Yeah, I mean, I think this works a little better when it's conversational, right? It's not me just talking to slides, which can get a little boring. But I'm happy to do it that way, or whatever, however the spirit moves us here. So, but happy to go on a solo or a group act that we've now formed.
Okay, perfect. Now we will stay in the call. So
sure. And so let me see if it'll let me advance here. Yeah, there we go. So when we think about this journey that we've been on with the industrial metaverse, we've actually it's been going for some time, right? It's not just sort of a more recent occurrence in history where everything is kind of technology and everything has come together. It's a thoughtful progression of enterprise throughout many decades and centuries of manufacturing, and it really comes down to the digital transformation and modernization of both your physical and digital systems. Sorry, I'm not used to the animations yet. But so when we think about the industrial metaverse, the tenets that Microsoft is really going to focus on are AI, digital twins, simulation, mixed reality, machine learning, and cloud to edge. And really that all is under the banner of people and AI working together. So the one concept that we want to anchor people on, or organizations on, with the industrial metaverse is it's about people and AI working together. We're not here to, substitute, the workforce with AI, right? It's not all about robots. It's not all about automation. It's about improving workers' lives, and, be they in the front office or frontline worker with technology at its core. And so I thought it would be good to talk a little bit about what the industrial metaverse is from our perspective and what it's not. And so what it is a lot easier to talk about once you've put it into context of what it's not. So let's start with the consumer metaverse. So for us, the metaverse, quote unquote, is really comprised of three segments or sectors. It's consumer, it's commercial, and it's the industrial metaverse. So when we talk about the consumer metaverse, that's really the gaming and retail and the noise that is currently in market with Meta, and we have legs kind of attitudes about these virtual worlds that are being stood up and created, and they're trying to attract consumers to. It's about in-app purchases, NTFs, it's the retail experience that I mentioned, where the commercial metaverse is more about how enterprise organizations collaborate. So teams mesh, some virtual world, some avatar right there in that collaboration space, but it's those are separate from how we're thinking about the industrial metaverse. So the industrial metaverse is not crypto, it's not NTFs, it's not blockchain, at least today. It's not in-app purchases. While there are some specific MR, XR, AR applications within the industrial metaverse, they're very scenario based, right? It's frontline worker connected. It's collaboration connected. It's not all about, mixed reality in many senses of the word. And so the problem that, in our eyes, that the industrial metaverse is really trying to solve is you have a lot of data. You have data that is siloed, and digital transformation is not the goose that was promised to the world, right? It didn't solve all of our problems. We have all this data that is connected in parts. It's still disconnected and not accessible to the organization broadly. And so what the industrial metaverse and its technologies enables is it creates insights from a common data formulation or foundation or model to optimize existing business practices and systems so that they can develop new products, services, and experiences, both for their workers and for customers. And so when we talk to, and this is really industry agnostic for us, right? All of the slides that we'll talk to, at least at the front top of this deck, it's all industry agnostic. So when we think about what are the challenges across industries, across organizations that customers are trying to solve for with an industrial metaverse solution, it's, they're trying to get a handle on connecting that physical and digital systems and data. It's having visibility and having it real time into that information, be it internal information, but also external, right? Because once you go outside of your factory or whatever bubble, there's a lot of external factors that you need to account for within your supply chain, for example. It's reducing capital costs. It's trying to be, as an organization, more sustainable, from just broadly energy consumption to producing less waste, having less downtime. So being more sustainable as a business. And then ultimately, something that I think every industry will be challenged to solve for is this, skilling their workforce. Right now, especially in manufacturing here in the US, we're seeing a lot of folks age out of their current roles, right? Because they're just older now and they're retiring from their current employers. And so you have to, one, onboard a whole group of new employees, but then two, at the same time, retain all the knowledge that Mary has been working in an automotive factory for the last 20 years. She has a wealth of knowledge that in her head that we need to capture so that we can maintain efficiency in operations and not have downtime and not have, we can work through problems at scale rather than having to, completely retrain somebody brand new and have them, just shove them into a situation that they're not necessarily equipped to handle day one.
Yeah, and I think as an addition, I think this is actually good because it is also about, you see a lot of companies where there's a lot of workers who only work a few months to half a year.
Yeah.
They take out the knowledge. And in some way you want to maintain that knowledge. And that is a difficult thing. But you also want to prevent every time the experts training the new people again over and over and losing that time.
Yeah, I mean, to that point, Alexander, right? Like I talked about the metaverse broadly as, they are these separate entities, but that's not really true, right? They're more of a Venn diagram of overlapping segments of the metaverse. So there are, when we talk about collaboration, it's collaboration from a office perspective, the enterprise perspective, but it's also frontline worker. So that like Teams is applicable. The collaboration is applicable within the industrial metaverse. So it's a little more fluid than I guess initially painted.
Can you also say that this is also about getting the right data to the right role in the right situation. So talking about contextual information.
That's exactly right. Right. It's about getting the right data to the right people at the right time, so that they can make informed decisions and take action as a result of the, make a decision and take an appropriate action, right? Without having to form a committee or, do some sort of Kaizen event to figure it out, right? We have the right people, the right data at the right time to, pursue a specific course of action. And so when we look at, and these numbers come from McKinsey, I think they're from last year, but when we look at the opportunity that an industrial metaverse solution or technologies ecosystem create, it's really around those pain points, right? It's reducing your inventory costs. It's visibility or accuracy within your forecasting, right? So connecting that data together allows for really substantial forecasting in real time, right? It's, increasing labor productivity, throughput, all of the things that obviously manufacturers care about, and obviously reducing downtime of those processes and systems. So there's a lot of benefit today with the technology, the industrial metaverse technology that we have today. But, I think this will only grow as we, add technologies in the short term and the long term. And so,
sorry.
No.
So because so you have all those benefits and through the using industrial metaverse, but I can imagine you also have quite a lot of effort in the beginning, right? You just mentioned like capturing the knowledge that's in somebody's head, right? And that's not something that's out there. Someone has to kind of get it out and model that kind of data, and basically you're saying even with all that work you have to do in the beginning, you still get all of those effects basically in the end.
Yeah, and it's not, and we'll talk about this in some of the slides coming up. It's not, and don't think of these like as a stepwise process of I have to fix my OT and IT data completely. It has to be perfect and beautiful for me to have any sort of benefit, along, downstream. In our eyes, there are specific access points and challenge points that an organization can target today and see real value from, right? Be it IT, OT data, right? That is one. And it's a common one across organizations, but it's also digital twins. It's also simulation. It's also, the machine learning that we talked about. It's the skilling, right? Those are all decision points where if I'm a manufacturer and I want to solve, like I have a big problem with training or visibility, like let's go solve that. And then look at all of the things that are opened up as a result of, fixing that one specific issue by then connecting it to everything else that we have in our, ecosystem. And so when we think about, let's go back to ground everyone again in terms of how we see the industrial metaverse. It's really that it will always come back to, as a lot of Microsoft principles do, it's focused around people, but it's about people and AI working together, bringing that physical and the digital together. In this sort of organizational loop of design, build, operate, and optimize, right? So that is a consistent loop that an organization will have with its people and systems and data to drive real and specific outcomes based on their industry. And we'll do that in true Microsoft fashion. We'll do that with partners to, deliver specific outcomes and technologies, both ISV and SIs, right? Because, we have our skill set, but we recognize that partners are a big part of how Microsoft operates and how we work. And they bring expertise and tool sets that are very important to realizing the industrial metaverse. Sorry, not used to the animations. So these are those challenge points, right? Or access points that I was sort of talking about, right? To your question, it's about, okay, yes, we have data issues. Everybody has data issues, but like, what are some manageable things that we can tackle today? And as a result of that, maybe it's, okay, we've opened up some digital twins, and now we have real-time OT data coming into our digital twins, so we can create digital twins in real time or modify them in real time using that OT data. Skilling our workers and the knowledge transfer. Obviously, we have Microsoft has a lot of tools to do that today, from HoloLens as a point solution or point hardware technology to guides and remote assist, right? That's sort of a knowledge retention and skilling tool, an important tool that we have today as a part of that pillar. And then it's, okay, well, let's think about how do we connect our digital twins to simulations and machine learning, so that we can optimize both their creation, but then also the development and design processes within our organization, so that we can shorten those lead times in terms of designing a new product, designing a new process, designing a new system or flow. And so, while these are not comprehensive in any sense of the word, from our engineering perspective, these are many of the use cases that we're validating today, right, from engineering. And a lot of these, like remote support and management, operations with automation, what if analysis, these are possible today in some capacity, and we only see them getting better and improving with the industrial metaverse technologies today, and as they advance further.
I think that this also shows what the power is of Microsoft, because a lot of people just look at a single product, and what you see here is that all those products and services together actually bring that power to you. So being able to use remote assist to get an inspection or audit done, having a Power App running in the background to get real-time data from IoT sensors, which goes to the IoT app. So all those services which are already in place, there's just not saying it's only connecting and it will work, but it is not so difficult to do this today.
And our real goal here is to, again, these are industry agnostic, right? These situations and scenarios are present across, whether it's manufacturing, whether it's healthcare, whether it's consumer packaged goods. So our goal is to build once, modify slightly for the industry, have industry specificity, and then sell many in terms of, okay, well, here is your manufacturing pillar, here is your for you consumer packaged goods folks, here's yours, healthcare, here's yours, right? It's so you have the breadth and the depth, but also the fidelity of your specific industry and industry use cases.
I got a question from someone. So the question is, what is really different, thank you, about the Industrial Metaverse versus what Microsoft has been doing with their AI, mixed reality, Azure, and partner networks?
So it's a very broad question. Yeah. And so it's more, at least from our perspective, like what you're seeing with AI, that's a small piece of the industrial metaverse. It's a big piece, right? It's as we integrate AI and technology with people, but it's one piece of a whole. And so our goal is to better create or build this ecosystem across Microsoft, right, that connects both our technology and partner technologies together. So it's not just about AI. It's not just about Azure. There are other technologies here that, we're in a very nascent space, right? Tomorrow the landscape could change, but a new technology could be invented where we'll have to adjust and, account for. So it's not just about like, yes, AI, as the news around ChatGPT has everyone in a tizzy around the world right now. but it's not just about AI. It's not just about, okay, we're doing that specific sort of supplementing of workforce with AI. That is a big piece of it, but there are other technologies here that are important and could be just as integral to the industrial metaverse as it grows.
Yeah, as I said, all the products bringing together the power.
Yeah. And so really, when we talk about AI, so that question was a good lead-in. It's about making AI achievable and conceivable, right? Within specific situations. It's automation for those purposes. It's assistance for those purposes. So like the frontline worker experience that I gave with guides and remote assist, it's tagging information to your work environment, be it an asset, be it a machine, be it what have you, so that you can, as a new worker or an experienced worker, tap into it and understand, okay, here's how this machine works. Here are some pitfalls. Here are videos. Here's a list of experts that I can tag into or tap into to if I run into a problem with my particular station or machine. And then it's about autonomy when autonomy makes sense, when we don't need or the ask is beyond the person's compute capabilities, right? Like we are humans are limited in our ability to think through calculations very quickly. So let's have a computer do that, right? Let's do it and have it run through all of the scenarios much faster than it would take us to do as a group. And then I won't spend much time on this, but as we look at the sort of design, build, operate, and optimize, here are those value props and use cases, of the technology that exists today across those phases, right? So really kind of grounding people in there's a lot of value propositions here today, but we will add to this over time as an organization and as new technology comes available. And then I know this slide might look a little busy, but I wanted to just talk through because it really kind of represents the industrial metaverse for us. And I think I took out the sort of individualized look of this, but essentially this slide represents that design, build, operate, and optimize loop with, the design pieces really around your PLM and, having that data integrated to your IT and OT data. Excuse me. But then build is really, when you add your ERP and sort of IT system data to that. Operate is really, the sort of bottom half of the page here with your physical systems, your OT data being gathered, to contextualize, formatted in a way that makes sense, so that you can build those digital twins, so that you can run AI and simulations. And so the optimization is that sort of last piece, the AI and simulation piece. But, this to us is sort of the industrial metaverse today, and it will only expand from here. And so when we look at industries, right, these are the industries that Microsoft, how we sort of think about industry from a sector perspective. And so as we go to market with our industrial metaverse offerings, we will have, as we walk through, right, we'll have this sort of broad industrial metaverse positioning, but we will be really looking at it from a specific industry lens and use cases, right? So what are the things within manufacturing that manufacturers care about and that we really need to help them solve for? Same with consumer packaged goods and retail and healthcare and et cetera.
We got another question.
Sure.
Let me pull it up. Oh, it's already done, I think. No, let me do it. From Workaholic, I like the name. For a non-technical business leader, where could we start to explore leveraging industrial metaverse tools to determine how to improve operations? finding a good use case to pilot. So
yeah, so I think it depends on your maturity, right? So what I didn't show here, and what we will have in this larger deck and larger perspective, is how to get started based on your maturity as an organization. So within even, and we will break it down by industry. So based on what you're trying to solve for and what are the use cases that you're really trying to achieve, or the outcomes that you're trying to achieve. How do I think about, okay, starting today versus what comes next versus what is sort of tomorrow, from there in a stepwise fashion, right? Because we don't want to get into the digital transformation trap of, oh, well, you're going to do this thing, it's going to be great, and everything will be solved. No, this is a process, but there are different entry points that you can access to solve specific scenarios. So if it's IT and OT data, bringing that together, that's important. But there, it varies by your, how you approach that can vary by your maturity as an organization.
Yeah, I had another question. I actually get more questions. We actually answered this one with a link, but I still want to show it up because I think it is a question which is on a lot of people's minds. I know there's a lot being said about this.
Okay.
But Microsoft has canceled the HoloLens project. I know from a fact that it's not canceled, but
yeah, okay.
I think they are more pointing towards the future, especially with the fact if there is new devices coming up. But yeah, I think you can best answer this one.
Yeah, so I really like my job, so no spoilers today, sorry. But yeah, to answer the question, HoloLens projects aren't canceled. HoloLens, as Satya, I think it's hard for when with an organization like Microsoft, it's so big. When we make internal changes from the outside looking in, those changes look like huge dynamic shifts, right, from the outside perspective. It's not usually the case. So HoloLens is still alive and well. It's still a strategic priority for Microsoft, as Satya said, as Judson has said. So the changes that have been alluded to in the news are more about us getting organized around delivering on delivering value to customers in a meaningful way, and how can we best do that, given our current and what structure it lends itself best to that process.
Yeah, I agree on that one. It's and maybe from I'm actually working for a very large partner of Microsoft. We're definitely not ditching anything around this subject because we still see a very good future. If you combine it with the Industrial Metaverse, a lot of people think when we talk about Metaverse, it's always about VR or AR.
Yeah.
It doesn't per se have to be. We are doing projects which using different front ends, which has nothing to do with VR or AR, which still falls under the name of Industrial Metaverse.
And I think it's, part of it is, the HoloLens is a priority for us, but it's, it's sort of a point in time technology of, some new technology could come out and we will have, we need to adjust for that. And it's really thinking about how do we think about these products from a deplatform perspective of let's not just have everything on HoloLens. Let's have it on mobile. Let's have it on Surface. Let's make it accessible for everyone, regardless of the hardware that you're using, because that really drives value, right? Having it in your daily life as part of your daily routine drives the value, not necessarily having it through a particular access point.
Correct. HoloLens, just like all the other things, is just a way of.
And Quest the same.
Same goes for Quest, indeed. Yeah.
Deplatforming as well.
I got another question, if you don't mind. We have a lot.
Yeah, please.
So this is from Richard. He's saying AI is disruptive. I agree with that, especially at the moment. What is the conservative goal to have majority of the market utilizing Industrial Metaverse, be it will be Microsoft or other corporations? would this be small business or just mid-large size businesses?
I think it's there. It probably will be. It will probably depend. For the full breadth and depth of the industrial metaverse, right? I don't really see, at least in the near term, small and medium businesses using robots and large, expensive compute AI brains to run simulations, right? But collaboration from a small and medium business, that's still the industrial metaverse. That's still, training your frontline workers through Teams and through Mesh and through whatever other, devices and platforms. Very applicable. But so it's probably a stratified view of the technology and the adoption curves within specific segmentations of businesses, right? So from enterprise on down, so strategic and mid-major and whatnot. In terms of what are the technologies that make most sense for your industry, your segment, and how do we enable you as a segment to start that adoption curve or accelerate it?
Yeah. Another question I have, I find this an interesting one, which I actually get a lot when I'm talking about this subject. The problems and use cases you have listed have been around for a long time. What different does Industrial Metaverse bring to the table which other existing tech lacks?
I think it's so. Yeah, I mean, it's the combination of technologies that we're, at least from my perspective, right, or in part, it's the combination of technologies. It's taking, attacking a use case from this like monolithic perspective of, well, if I transform this one part of my business, then everything's going to be solved downstream. That we found that's not the case. I think when you look at digital transformation broadly, still like 30% of digital transformations fail on a regular basis, and 7%, I think it is, or around there, that are those digital, of those transformations that were successful, are fully implemented across an organization. So your data is more open, I guess, or more inclusive, but it doesn't go far enough, right? You're still looking at a very myopic view of your business, and you really need to start thinking about it more from that design, build, operate model, and how does the technology that we have that is available and coming that can help unlock it for everyone, right? Not just a specific group within your organization.
Can I have a small addition on that one?
Yeah, please.
So for me personally, it also has to do with, and I think, and it adds on what you were saying, is that if you look at today's technology and what is possible, also the fact that we have higher speed capabilities of data transfer, allows us now suddenly to have those experiences we had many years ago more easily click together, but also the ability to experience them together with others instead of only person getting the data. So in being able in the same room in some way, or sharing data, sharing real-time experiences together, even when you're not in the same place. Yeah. And I think that's something which is definitely a capability which came up within the last 1.5 years. And that is definitely driving a lot of industrial, on top of Industrial Metaverse.
Yeah, exactly. I completely agree with that.
I have a follow-up for that as well. Because the things you're showing us today, how much of that is already available to the consumer today, and how much of it is like in the near future? And can you?
How much is fantasy? How much is reality? Everything that we talked about today is reality, right? In some way, right? Depending on your maturity, right? You might not leverage everything, but everything we talked about from those challenge pillars, those are all available technologies, right? Today, that
like the AI assistants and
yeah, absolutely.
Okay, cool.
It really comes down to your maturity as an organization, and therefore your ability to leverage that against a specific use case or scenario.
Yeah. No, because I'm asking because things like mesh, people have been waiting for a while and it's still not available. And so I was wondering how much of what's the state of the other technologies that you're showing?
Yeah, so mesh is not my department. I have colleagues on the commercial metaverse side that I talk to for that. But yeah, there are coming releases around mesh in terms of the enhanced capabilities and functionality. So basically stay tuned.
Thanks.
So, Alexander, I don't know how much time we still have left. I don't want to eat into Jim's time.
We have around 5 to 10 minutes, and Jim is already getting himself ready. So
yeah, great. So I don't know if the next few slides here are just really around the outcomes that we look at from an industry perspective, right? So sort of double clicking into those broader scenarios. And then, when we're starting to think about how to initially target within, say, manufacturing, here's how we're kind of thinking about scenarios within manufacturing. And, then we just break these out into their individual slides. So just moving through these pretty quickly.
I actually got another question.
Yeah, please.
That's actually an interesting one. Again, from Workaholic.
He's working.
He's working, definitely. Maturity. Sometimes businesses think they are more mature than they really are. How does a business assess readiness? That's a really good question, actually.
It's a great question, and I think it's something that we're going to have to help them with in terms of what makes. And it'll probably stem from taking an honest look at your business in terms of, a lot of businesses, and prior to my current role, I worked on the BizApp side of our house, now BizApps in modern work, where I was helping our on-prem CRM and ERP customers migrate to the cloud through a specific program. And so what we found there, and I think it's applicable here, is, a lot of organizations don't really take a stock in where they really are today, right? They kind of have, we've made all these technology investments and therefore we're getting value with them, even though they might be siloed and they might be, pushed to the side in a specific area of the business. And so I think it'll be up to us to help sort of tease apart those conversations and really dig into, okay, what are the challenges that you're facing, right? And I think it applies to the slide that we're looking at now of, do you have a real problem around quality inspection, or maybe it's that training issue within your manufacturing solution. So let's really talk about what's going on in your business and why things aren't working the way that you're expecting them to. And then from there, we can really, okay, based on that, you're really kind of here in the maturity, or, in the first third rather than the middle third, or, the last third. And because of that, here's how you should start thinking about the broader technology access that is available to you based on that maturity and based on, just the available technologies.
Yeah, I agree on that. I know there are assessments possible out there. I'm not a big fan of those things because it only gives a very small perspective, and I think it makes more sense indeed to look at your challenges and see what you currently are leveraging already and see where you can grow. Because
and I think it's looking at those investments that you've made.
Yes.
Right. Let's not ignore those investments. Let's pull them into a broader perspective of, okay, well, we made this, an IT investment over here, and we've made a OT investment over here. How can we start bringing some of these siloed investments together for a larger impact across the business? Not just, okay, well, we have some visibility over here. Let's amplify that impact by making meaningful connections with the available technology.
It's not only that. I mean, maturity differs per company because every company has different needs, different investments. You can't put that all under. We have manufacturing assessment. We have it doesn't work like that.
And it gets complicated, especially when you're looking at manufacturing, because you might have 50 factories around the world, but each of those is a unique snowflake. And so they have their own challenges that you're going to have to solve for in, maybe it's, you have a similar system, but like there are small tweaks you're going to have to make and consider. But the industrial metaverse technologies should be able to help there.
Perfect. I think we can round a bit up because we're almost at 8.
So I don't have a big, splashy finale, but it was a pleasure chatting with you all today, and look forward to doing it again soon.
Yeah, thank
you so much. Thank you for your time and for being here, and also at very short notice you did this talk for us. Thank you so much for that. Yeah, there's no more questions in the chat, so thank you everyone who's watching for your questions. And I would say, let's wrap up and then continue with our next.
If you have questions, you can find me on LinkedIn. I'm available. I'm out there in the world, so happy to. If you have specific product questions, can connect you to folks, or happy to do it.
Perfect. Thank you so much.
Perfect. Thank you.
Yeah. Thank you.
Thank you so much.
Okay.
So it was a great talk.
That was really good talk.
I hope Jim is ready. Our next speaker is Jim Bennett.
Oh, he's definitely ready.
He's nodding.
Yeah, I'm ready.
Jim.
Thank you very much.
Thank you very much. It's great to have you.
Yeah, thanks for being here. We're looking really forward to your session. So.
Yes, right. Your session is going to be on data visualization from clay tablets to the metaverse. Correct?
Yeah, we're going to be covering 6,000 years of history. So
amazing.
Yeah.
My first question would be clay tablets. So the first thing I think of with clay tablets is Snow Crash, the book that they've also coined the term metaverse, because that book is also about Sumerian clay tablets. Were you inspired by that in some way, or is it just coincidence?
It's just coincidence because I've never actually read Snow Crash.
No, you should.
I have never. Yeah, I've read the classics. I mean, Neuromancer is one of my favorite novels of all time. Ready Player One, obviously. But yeah, I've never actually read Snow Crash. I need to. I know it's where the term came from, but yes, I have not done it. So yes, this was not inspired by that, but I probably should go back and read it and actually see if there is a link for what I'm talking about today.
Okay, so shall we give you the stage?
Yeah. So you can bring up my screen.
Let me add it.
Awesome.
Perfect.
Okay. So thank you, everyone. Thank you for joining. Thank you for coming to listen to me cover a few thousand years of history. So for those who don't know me, I'm Jim Bennett. I'm a cloud advocate at Microsoft. So I'm on the engineering side. Tom, as you saw, was very much the marketing business side of things. I'm an engineer. I build stuff, but my job in advocacy is to help developers be successful with Microsoft technologies. So I do events like this where I talk about things, but I write blog posts, videos, sample code, all that kind of stuff to help you be successful. I'm all over the internet at Jim Bennett. Thanks. We've just put the link in the chat there. Thank yous. But link.e/JimBobBennett. You can access my Twitter, Mastodon, LinkedIn, GitHub, all there. And if you've got any questions about today, feel free to reach out and ask me questions. So I want to start with a question for you all, something to think about. What do these two things have in common? We have this kind of grey tablet with scratches on it, and we have a HoloLens too. So what do these two things have in common? That's kind of a question for you all to think about. And they actually have quite a lot in common, despite them being very different. And I don't just mean they're kind of rectangular shaped and they're grey. They have a lot in common. So this first one here, this is a clay tablet from the Minoan civilization from Crete in Greece. This is from about 1375 BCE. It's about 3,500 years old. And all these marks on here, this is writing. This is what's called Linear B script. It's one of the earliest forms of writing. And this actually records offerings to religious figures and gods of oil. So to this priest, we are giving 3.6 liters of oil. To this god, we're giving 19 liters of oil. And this actually tracks oil gifts to religious figures. If you're interested to see this in person, it's in the British Museum, along with a whole lot of other treasures that the Brits stole and probably should give back. So yeah, ancient clay tablet, 3,500 years old. Now we jump forward to 2019, and we have the HoloLens 2. Augmented reality device. You can overlay 2D and 3D information over the real world. Absolutely powerful device. So Richard actually tries to answer the question with information. Yes, it does. It's all about representing information in different ways. And that's really what we're going to be talking about in this session, is how we represent information. Great answer. So this HoloLens, I've actually got one here. Let's stick it on my noggin. Just power it up. Give it a second to wake from being sleepy. And rather than showing you some oil gifts to gods and priests, I'm just going to launch another app. Just get a live preview going. Hopefully it's going to connect. Okay. And what I'm going to show you on this is, where is it? It's over here. It's the International Space Station. There it is, International Space Station. And we have some live data coming from the International Space Station. So you've got kind of two ends of the technology spectrum here. Just going to stop this for now. So we've got this tablets from 3,500 years ago, and we've got something like this HoloLens that shows the ISS, the sign of the modern world. Claudia says, what's the name of this device? Yeah, this is the Microsoft HoloLens 2 augmented reality device. So it's not like the big ones that cover your entire face. This is very see-through. It's designed to be augmented rather than support virtual reality. So what these two have in common, that was the video I was going to do if the demo failed. There we go. What these things have that makes them the same is they both visualize data. The whole point of these devices is to show data. The clay tablet was how someone was showing the gifts of oil to religious figures. The HoloLens is how I'm showing the metaverse, the industrial metaverse, that I'm showing ISS data. We're still finding ways to show data. They both visualize data. So what is data visualization? Come on, computer, you can do it. Yay. So what is data visualization? Data visualization is the representation of information in the form of a chart, diagram, picture, etc. Can be a table. Some people say yes, some people say no. But the idea of data visualization is to take a large quantity of data and represent that in a way that people can understand quickly. We want to see the quick differences between values. We want to see trends, images. We want to be able to ask questions of our data. And that's easier to do with a picture. The old adage of a picture paints 1,000 words. So the idea of visualization is we spot patterns, we ask questions, we get information about large quantities of data in a simplistic way that we can then collaborate on. And I've got a fair few examples of this as we kind of go on our history lesson. So let's start our history lesson. 5,500 years ago, just over, in Sumer, the home of the Sumerian civilization. This was in the southern end of Mesopotamia, in what is now Iraq, right on the Persian Gulf. And this is kind of where some of the strong part, the earliest parts of the written word came from as kind of the rise of this civilization. And they actually used a thing called what we call now proto-cuneiform. So one of the earliest written languages, and they used it to track items and numbers. It wasn't really used for telling stories that we know of. It wasn't used to document your life. It was used to pass on information. Most of the tablets from this era that we found have economic records. So this example here is tracking allocations of beer. But they had a lot of records like this, tracking sales, gifts. It was the idea of here's an item, here's the number, here's the item, here's the number. And as the language evolved, it almost started with numbers and items in one image and kind of split into two. Also, they found what's called lexical lists. So a list of tools, a list of cities, a list of metals, things like that. But most of it was used for accounting. And the numbering on this, the numbering system they used is what's called sexagesimal, which is actually a numbering system we all use all the time, and you probably have used it today. Sexagesimal is base 60. And we still use this in two big areas in the modern world. Circles, 360 degrees, but also the clock, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. This is all based around sexagesimal numbering. In fact, let's have a quick lesson. If you can make me my camera full screen, please. I can give you a quick lesson on how to do sexagesimal counting and how to count to 60. So yeah, if possible, can we change the layout so I'm full screen, the camera's full screen rather than that's it. Thank you. So sexagesimal is based off your hand. Yeah, we do decimal, 10 fingers at the moment. Kids learn to count to 10 on their fingers. Sexagesimal is actually based on 2 hands, but using the bones in the fingers. So when we count, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's how we count to 12. And then the other hand is a multiplier. So once we get to 12, we have 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And so on and so on and so on. We get up to 60, 5 12s. So that's where the idea of counting in 12s and counting to 60 goes. So this is a thing you can amaze your friends with, counting to 60 using your fingers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then use the hand for multiply. Awesome, thanks. If we can get the screen back up, please. Thank you very much. So this is why we use the 12s and the 60s. If you're wondering why it's 60 seconds in a day, it's because it came from, well, it started out with the Sumerian civilization and moved on from there. So this protocuneiform is great for small quantities of data. If we want to record beer allocations, we can do this on this tablet. But back then, really, there was only small quantities of data. We weren't dealing with the vast quantity we have today. Now, kind of the next step really in visualization was the rise of the map. Maps are incredibly good ways to visualize data that has a spatial side to it, some form of location-based characteristic. So the first map of what we think of as a map was actually there's the Babylonian map of the world. The jury's still out exactly when this was first made. It's probably 7th, 8th century BCE. So, you know, we're looking at 10,000 years old, potentially. 3,000 years old, almost. And this was designed to show the known world based off from Babylon. So Babylon was pretty much the same place as Sumer. It's part of southern Mesopotamia. And this map kind of shows that area. It's based around the Euphrates, a river that goes from Turkey through Syria, through Iraq into the Persian Gulf. And it shows cities, it shows mountains, it shows where the sea is, and just generally gives you that visual representation of the world at the time. You know, it shows where Babylon is, it shows where Urartu, Elam, and Susa are big cities of the time. So that's kind of representing information on a map, location-based information. And this kind of illustrations like this on the map kind of help represent largish amounts of data, like distances or where things are. Now, maps evolved over time. When we hit kind of the medieval period across Europe, there was what's called Mappa Mundi. Absolutely gorgeous maps these are. And these are designed to show the world with illustrations to share more data. These are often circular, because even in medieval times, we knew the world was round. We've known it's a sphere since ancient Greek, Roman times, if not before. The whole flat earth thing is utter nonsense. People did not believe that in the Middle Ages. But these maps not only showed the location of places, but they showed data around that. They showed data based off stories, based off climate, based off what is there in each particular place. So, for example, you would get zonal mappa mundis, where you would have a map of the world showing climate. Up north, it's cold. When we hit the equator, it gets nice and warm. There was mappa mundis that would show a whole lot more, the idea of what they call complex maps. And these would show here where our animals are, here where stories came from, here's where certain people live. This example here is called the Hereford Mappa Mundi, found at Hereford Cathedral. This is from 1300 CE. And if you were able to get up close and see, you'll see elephants on here from parts of Africa and parts of Asia where there are elephants. You will see the Minotaur in Crete, telling that story of the famous Minotaur on Crete, Mount Olympus, the stories of the Greek gods. And so it combines the location of stories, animals, with this physical map. There's actually a big mistake on this map. They labeled Europe and Africa around the wrong way, which is kind of amusing. But this was all about bringing data through stories onto a map. It's kind of getting quite advanced now. We've got places, we've got people, we've got animals, we've got climate. The next kind of step with maths, we're going to keep with maps for a little bit, was a choropleth map. These were invented in 1826 by Pierre Charles Dupin. And the idea of this is you would use shading on a map to indicate numerical data. You didn't care about the actual numbers, you cared about almost like the relative nature of those numbers. And so he was looking at education levels, particularly illiteracy, across France. So we had a map of France divided up by department, which is kind of administrative areas of France, like counties. And on that map, he colored it in, or shaded it really, because this was printed before color printing. He shaded it based off the levels of education. And so very quickly, you could get this map out and look at it from a country level and say, which areas have a high level of education, which areas have a low level of education. You know, what was a table with a lot of rows indicating education levels and schools and all that, huge amount of data, suddenly becomes a single image. And it's very quick to ask questions of this data. You want to say, where are the areas with low education? You can pinpoint this on the map. Oh yes, it's that area around Brest. Oh yeah, it's that area in the central France has lower education. Oh, as we go further north, we've got a higher education. This is kind of where the idea of gathering data for government level planning, urban planning comes in. If we can put this data on a map, we can very quickly look at regions that have associated data with them. Now, as the level of data went up and up, these maps became a lot more important because they had to filter this data. They had to represent a huge array of data in an easy to understand way. From there, they moved to what's called flow maps. These were invented by Charles Joseph Minard, a French civil engineer. He started off monitoring traffic in Dijon. And this is the map he created using lines of certain thickness to indicate the flow of traffic and the directionality of the traffic with color. So very quickly, thinking like urban planning, you can see where people are going, where people are moving around, and which areas you need to invest in. You want to charge people to come into the city, you can find the gates they're coming in if it's a walled city. You want to manage traffic flow, you can see where people are coming and widen the streets or redirect people through a different route. And even today, we see this. If you use Google Maps, traffic is indicated via essentially a flow map. They're using colors on the map to indicate where traffic is, and it's directionally based off where you are traveling. So it's a great idea to bring a lot of data gathered over the time onto a map. We still use this now. You see traffic cameras and the rumble strips on the road to monitor vehicles to produce this kind of data. Back then, it was Charles Joseph Minard sitting there with essentially pen and paper capturing this data. Now, a really cool use case with visualizing data on a map to answer questions is the use of maps to track cholera. This is one of my absolute favorite stories of the use of maps and data. So Jon Snow, not the one from Game of Thrones who knows nothing, but Jon Snow was a scientist back in the 19th century. Now, back in the mid-19th century, the prevailing theory around disease was it was spread by miasma, bad air. You know, maybe with the current COVID situation, maybe there's some truth to that. But certainly diseases like cholera, the scientists at the time thought it was bad air that spread these. And one scientist, Jon Snow, thought, no, I think water might be the way this is being spread. Didn't really understand how. The idea of germ theory wasn't really put forward to Louis Pasteur in 1861. But back in kind of the 1845 to 1850 time, Jon Snow was looking at how water could be spreading diseases like cholera. And he started plotting on maps where the outbreaks were happening. And he was able to see that the parts of London that had the most cholera were getting water from certain water companies. And they were taking water out of the Thames, literally in the middle of London. And so you get cholera, it will go into the sewage system, into the Thames, and then it'll go back in through the water supply from these various suppliers. Other suppliers that pumped in water from further up the Thames had lower cases of cholera. And so just by using maps, they could say which water companies needed to change what they were doing. And it ended up being one very famous story that's questionable on how valuable this was, but during a big outbreak in an area of London called Soho in 1854, Jon Snow actually mapped this by street where the outbreaks were, and they were all centered around a street called Broad Street. And it turns out there's a pump in the middle of Broad Street, that someone dug a well, stuck a pump there, and it was the water from that pump that was probably causing cholera, because that is where all the people in the area got their water from. And so the handle of the pump was taken off, and that reduced cholera in the area. Questionable, because cholera numbers were dropping, but it was still kind of one of the famous stories of using data visualization to ask the question of where is this coming from and get the answer and solve an actual problem. And it turned out the theory is there's lots of cesspits around the well where you wash babies' nappies, the babies would have cholera, you'd be washing the nappies, washing the cholera into the cesspits, and it was leaking into the well. So that's kind of the theory behind where it came from. But yeah, Jon Snow really used data like this, visualize the data, ask questions of the data, and use this to guide public policy. Absolutely fantastic use of this. So we'll hop back a little bit, almost 100 years, to flip from maps into charts, another big area of data visualization. So charts really started in 1765. Joseph Priestley kind of created some of the first charts based around timelines. This idea that we have a time period and you can assign data to various points in time and very quickly visualize the relationships between data. So this particular chart he created was based off the men of learning from the kind of Greek times, based off the years that they lived from going back to just past 600 BCE to 0 CE. And you've got names on here with lines, dots when there's uncertainty around the particular dates. But you can very quickly see that Hippocrates, Socrates, Plato were all at the same time, whereas poets like Virgil came a lot later on. Kind of got this quick representation. Again, we want to ask questions of the data of when did someone live, who was around at the time. We can see this. Then from there, charts kind of started to grow. William Playfair, probably one of the founders of graphical methods of statistics, as it was called back in the day. He created a number of different types of charts. And now William Playfair was certainly a man who got about a bit. He was a Scottish engineer. He was a British spy, spying on the French, the British government. He was also, and I'm going to have to refer to my notes for this, a millwright, engineer, draftsman, accountant, inventor, silversmith, merchant, investment broker, economist, statistician, pamphleteer, translator, publicist, land speculator, convict banker, ardent royalist, editor, blackmailer, and journalist. So this guy got about a bit, but he really invented charts that we think of today. So the first one he came up with was the bar chart. Something we use all the time. My 10-year-old does bar charts in school. Fantastic way to quickly represent data. This example is exports and imports from Scotland. So on one chart, you can see how much goods were based off £10,000. So divided kind of into £10,000 lots, how much by weight of goods was exported from Scotland and imported to Scotland to and from various different countries. Now, it doesn't matter how much data goes into here. This could be data from one merchant. It could be data from 10,000 merchants. Doesn't matter. One person can take all this data and squash it down into a chart. And it's kind of very quick, again, to ask questions of the data. Who should you have a really good treaty with in 1780? Well, Russia are buying a lot of your exports. So Russia are importing a lot of stuff from Scotland. Therefore, you need to make sure that you keep that relationship really good. Isle of Man, not so much. Maybe don't worry too much about the Isle of Man. So you can start asking questions of this data and use this to kind of make those decisions on things like foreign policy. William went on to create time series charts. And so a time series chart is when you have time across the bottom and a number up the side, and you kind of plot the change in data over time. So here is imports and exports from England to Denmark and Norway. And we can see from 1700 to about 1753, there was more imports than exports. And then when we hit 1753, it flipped, and England was having more exports to Denmark and Norway than imports. You kind of watch it grow over time. Really great way to visualize a huge amount of data. He also invented the pie chart, because he doesn't like a pie chart. Turkish Empire, how much of it's in Africa or Europe, and in Asia, all divided up in nice pie charts so you can visualize it. So this person was really good at coming up with charts, and we still use these today in everything that we do. So why have we gone from this clay tablet to these charts? maps, things like that. And the answer is we want to make complex data easier to understand. Over time, the volume of data has gone up. From one person tracking beer in Sumer 5,500 years ago to someone tracking the imports and exports of part of the European economy 200 years ago. We've got a lot more data. So we need to make this complex data easier to understand. We need to reduce data volumes. We want to convert large tables of data into simple images. When we have this, we can collaborate on the data. You can't go to an urban planning meeting with a printout, 1,000-page printout of raw numbers. No one cares. But you can go with one picture and you can change urban planning. And so you need to have this visualization so we can all have a shared experience to understand the data, and then still have that raw data if we need to do drill downs or we need to slice and dice it a different way. And so as data volumes grow, the techniques are needed more and more, and we need to keep growing our techniques for visualizing data beyond what we just do with what we could just do with charts. We need to keep growing more because we have starting to get more and more data. And this is kind of where the information age has kicked in and made our lives hard when it comes to data. The information age is the rise of the computer. And with the rise of the computer, volumes of data have gone up. The amount of data we can send has gone up. The amount of data we can receive has gone up. You think about the data you are gathering today. YouTube is tracking this live stream, tracking data around how many minutes watched, who's watching, things like that. If you go and watch Netflix later, they're going to track what you're watching, how much you're watching. If you've got a temperature sensor in your house, it's tracking your temperature. Your phone is tracking your location. All these different things. There's a constant gathering of data as part of the information age. Now, when we think about the kind of changes in human technical advances, they're based around three real stages. So the first stage was the transformation of materials, converting trees into houses, wheels, converting animals into food and clothing, converting these shiny rocks into iron for building plows and swords, things like that. We then moved to the transformation of energy. This was the Industrial Revolution, converting kinetic energy of water into kinetic energy of a millstone, converting the chemical energy of coal into kinetic energy in a steam engine, converting that kinetic energy into electricity. All this idea of we're transforming different types of energy to get the energy that we need. Mainly this day and age is electricity. And then we have kind of the information age. And that's about the transformation of information. We can transform materials, we can transform energy. Now we're looking to transform information. That's kind of where we are now. And so the way we visualize data has had to change and adapt to kind of keep up with this transformation of information. And one big area we get with this is the idea of dashboards. We don't have one chart anymore. We have multiple charts. The idea is we can put multiple charts in one place. We can look at a lot of different data values and make decisions based off multiple points of data. And what makes dashboards a lot more powerful as well, it's not just how many visualizations we can put on a dashboard. It's the fact that computers can draw these instantly. So suddenly we open up the capability for live visualization. We are not relying on William Playfair looking at 60 years of data and carefully drawing a chart that could take weeks to produce, to gather the data to produce. We've got instant live data. We can see what temperature is my boiler at. What is the current state of traffic through a big city? We can see this instantly. Computers can build these charts live, and suddenly we can start dealing with these volumes of data because we're not looking at a static picture. We are looking at live information. Yeah, you're considering imports and exports to affect foreign policy. Doesn't matter if your data's 3 or 4 days old. You're looking at general trends over a year. You want to see whether a factory machine is going to blow up. You want to see the temperature and pressure data straight away. It's going to got so much more capability with this live data. Now, kind of the next step in the data side of things was the Internet of Things. It's kind of my jam. I love IoT, but IoT really drove that data. It accelerated the rise of data generation. Instead of maybe somebody once a day sticking a thermometer in a machine, we have got sensors gathering that data every second. Factories, millions of sensors, millions of data points gathered every second. And this is getting just a stupid amount of data. The estimate is going to be something like 73.1 zettabytes by 2025. Yeah, not gigabytes, not terabytes, petabytes, exabytes, but zettabytes. Stupid amount of data. So how do we process it? How do we visualize that much data? Well, we can talk about AI, not going to cover that, but AI is one way to handle it. But really what a lot of people have been doing is storing it so they can build reports, dashboards, visualize it in either real time or historically. And so it's thinking about how do we take a huge amount of data that's generated and then visualize that. We want to see things before they happen almost. We want to see things as they happen. We want to get this live update of everything. And so we can do that with the power of dashboards and the power of live data being shown through the same kind of charts and graphs that William Playfair invented a few hundred years ago. So a quick example of a dashboard. Let's go back to the International Space Station, and I'm just going to show you a dashboard of live data from the International Space Station. Go here. Let me just refresh this because the video likes to drop. Let's start this up. Oh, no video at the moment. So this is a dashboard showing data from the International Space Station. NASA and ESA, the European Space Agency, got together to share all the data from the ISS. So we have live data from sensors on board the International Space Station that we can see here. The camera's not working at the moment, because it's being used to provide a live view of Earth following the end of life of the HDIF payload. It may come back in a minute. It's been on and off all day, but this would be a live view from the camera. But I've got a slide here that shows that was when it was over the sea at some point yesterday. But we can see things like position data. We're currently over the Indian Ocean. There's the timestamp, 11:26, like a minute ago, because there's a bit of lag in the data. But we can see in the last 3 hours, it started over Indonesia, up over the Pacific Ocean, down through Canada, North America, across South America, below the Cape of Africa, up through Indonesia again, back down, brushing North America, brushing South America, and is now in the Indian Ocean, kind of heading up to about to go through Thailand, Malaysia, China, and on. We're seeing the orbital velocity, seeing that go up and down. Nice smooth graph here. So we've gathered a lot of data going up and down because the Earth is not a perfect sphere. We're seeing the speed go up and down again because the Earth is kind of more egg-shaped than a sphere, so we get speed changes. So we've got these live dashboards, huge amounts of data coming from space, and we have this dashboard. Claudia asks, will technologies such as Chart.js, D3.js still be useful to show that live data in graphical format? Yes. Oh, yes. However you choose to slice and dice your data and show it, these tools are getting more and more powerful. So I haven't used those libraries. I've heard of them. I haven't used them, but visualization is so important these days. So the better the tools you can have to visualize data, the better you can make those decisions. So yes, these tools are becoming more and more important as we want to visualize so much more data. So it's the ability to create these kind of dashboards. Now, there's tools like Grafana that can help create dashboards. So you're not necessarily building it yourself. But yes, if you are building custom dashboards, then yes, the ability to use these tools is incredibly powerful. A lot of businesses rely on developers just building dashboards for them to show their data. Great question. Great question. So that's a dashboard. That's kind of where we're seeing this live data, which we could use to make decisions about the ISS. Do I go outside and point my binoculars up to the sky? I can make that decision based off this. So what's the next stage? We're gathering all this data in terms of IoT devices. What's the next way we think about the data? And the next way to think about how we visualize it is to tie it back to the real world, a bit like was done with maps. The idea of adding data to a map, like a choropleth map, is tying that data to the real world. When we think about IoT data, we will get better with our data if we can tie it back to the real world. So we're not just thinking, I have 4 temperature sensors and 4 vibration sensors, look at the data. We are thinking, I have 4 machines, each with 1 temperature sensor, 1 vibration sensor. Let's look at these 2 sensors, the data from these 2 sensors as one thing, and I consider this as one device. We don't think about just disparate sensors. We think, let's look at the device. This is all data about a device. And that's what digital twins is about. You create a digital representation of the physical world. That is the twin of the machine. And then you attach the data to that twin. You're really starting to drill down. You're taking the idea of maps of the world and applying it to physical machines in a factory floor. And that again simplifies the discussion around data. You're not looking at disparate data points. You're looking at a machine and the value that goes with that machine. Yeah. Oh, my temperature value is high. My vibration is high. What does this mean? Not great. Oh, this machine has a high reading on both its temperature and vibration. This machine has a problem. That is great. So having this ability to tie back the real world is incredibly powerful. So let's just do another quick demo. Let's look at the digital twin of the International Space Station. So we have this digital twin here. Here is our twin graph. So when we think of twins, we don't just have one thing that has data. We actually build relationships between things. I have a conveyor belt. My conveyor belt has 4 machines on that conveyor belt. These machines have 10 sensors on them. And I have this hierarchy of conveyor belt to machines to sensors. And then I can actually use that as like a model. And then if I have 4 identical conveyor belts, I use that as a model and create 4 twins that map to that model. So it's kind of a way of modeling the real world. And it gets very complicated. I mean, this is the ISS and just, yeah, it's a lot of stuff. And each one of these dots, which you can barely make out, is a node that has some data that we can see. So yes, we're starting to think about this idea of visualizing our data based off hardware, but we end up with this problem of we have too much data. So how can we visualize digital twins in the best way possible so we can, again, simplify what we see, ask questions of data, and make decisions? And that's where the concept of a 3D scene comes in. The idea of a 3D scene is you would build a 3D model, a virtual model that looks like your machine, factory, space station, whatever you're trying to build. You'd have that 3D model. And then you can then attach data to that model. And so you're visualizing not just like a flat chart, but you're visualizing a 3D model with coloring to show you information, with the ability to attach extra data to it. And it becomes a really good way to visualize a lot of data. And so let's actually zip back to the actual demo. Here we have a 3D scene of the International Space Station, and it's using color to show what's going on. So right now, the solar panels, they're flipping between green, yellow, orange, and this coloring is based off the power generation. And so if I click on a solar panel, I see kind of a live view of how much energy is being generated. And if I see something that's a problem, this one here, for example, keeps flashing yellow, I can see we're generating 29.6 amps at 161 volts, compared to this panel, 48.4 amps. So this panel is generating less power. So if I was on the ground at NASA monitoring the space station, I could very quickly bring this up and say, yeah, hello, engineering people, look, we have got the solar panel here that's producing less voltage. Here's I click on it, I see the numbers, I'm visualizing all this data. I'm visualizing the current, the voltage, the power output. I'm visualizing it over time. I've got this history here that I can see. So is there something wrong with this panel? And I've got this ability to then mine the data, make decisions, and use this to then tell the folks on the space station what they have to do. Claudia has a question. So I should assume those solar panels have sensors sending the data to the virtual model, right? Yes, correct. So up in the International Space Station, there are sensors everywhere, and it's sending the data to the space station and to NASA. So NASA themselves are monitoring the International Space Station from Earth via these sensors. So the data I'm seeing here is the same data NASA would see. They're literally publishing this data live out to the real world. So yeah, space station is absolutely covered in sensors, feeds the data into NASA. No idea what they do with it. That's their magic. But we are taking the data and we've put it into a digital twin. So it's really cool. This is all live data from the actual sensors on the space station. So yeah, great question. Great question. So we've got this concept of we can bring up the 3D scene and we can look at the data. So what's the next stage? Where are we now? What is the kind of the latest, almost bleeding edge version of data visualization? And the answer to that is the Industrial Metaverse. So Metaverse is a collective virtual shared space. Doesn't have to be with a headset. My daughter's in the Metaverse all the time in Minecraft and Roblox, the consumer Metaverse, gaming, people do that all the time. But the Industrial Metaverse is a collective shared space where we would look at data around machinery, where we would visualize industrial data. And so you get the idea of these 3D representations, you get the idea of the associated data, and you can visualize this data collectively. So if we all had HoloLenses, we could all put a HoloLens on, and we could all look at the International Space Station. We could walk around it, and we go, oh yes, that panel's generating data, that's doing things. We've got this shared experience where we can collaborate on the data. We can put a factory on a desk in front of us and talk through it and tap on things, virtual things, and see charts of that thing, look at the data, make decisions, collaborate, even if we're not in the same place. By putting on an augmented reality headset, we see avatars of each other as we're walking around a virtual model, making those decisions. That is happening today. But we can go even further than that when we start thinking about augmenting reality. If you've ever used those AR apps where you get like a QR code and you put the app on your phone and you wave your phone over it and like a character appears, and 3D character, and you move your phone around, you see the 3D character dancing, whatever. My daughter used to get a book from a local library, augmented reality solar system. Open the book, wave your phone nearby, and you get an AR version of the planet. You can move it around. So you can do the same in a factory. Put some form of indicator or just a detection based off the physical location that you are, that a machine is a certain device in your digital twins, and you can attach that data. So you could put on your headset, and obviously this picture here is very much a artist rendering, but you could literally do this. You put on a headset, and as you walk up to a machine, you would see floating in midair charts showing the data for that machine. So suddenly you could phone an engineer and say, got a problem with my hardware. Engineer puts the headset on, it's walking across the factory floor, they're looking from machine to machine, and they can see which machines have got the temperature too high, vibration too high, whatever. They can visualize that. Multiple engineers at the same time can do this. You've got this collective shared experience. So you're visualizing data at the device itself in the metaverse. Incredibly powerful. And so, yeah, let me just zip back to the ISS again. Start this back up again. Just to kind of dive through that. I mean, what we're seeing in, sorry, I'm looking sideways so that I don't get the ISS in the middle of my monitor. I'm just trying to get it off to one side. So with what we're seeing on this 3D scenes is we are seeing the live data. We can see on a flat 2D screen, we can see the numbers. So it's taking time to boot up. It went fully to sleep, I think. So let's just refresh this. Yeah, just wait for it to boot up. So it went actually to, there we go. That's better. Let's continue there. So come on, there we go. And I want, I don't want to take a picture. Go away. Trying to get this. Okay, it's gone crazy. It keeps taking pictures. I don't want to take a picture. Go away. Let me try and get the demo up. There we go. Right, and I'll just do the live preview so we can see it. Come on. Oh, no, it has decided to put it up on my monitor. Okay, but yeah, what we're seeing here. Take a second for it to appear, but I'm looking at the ISS. Now, if we all had HoloLenses on, we could all see the same thing. We kind of walk around, move things around, move my head around, look at different angles in the ISS. If I look up, I've got a list of solar arrays. I kind of point at one, and I get the live data. Let's pin that up there. So that's the Harmony module. So we can see the temperature, 4.5 degrees Celsius, cooling fluid temperature. Solar arrays, that's how much power that one's generating. And so we've kind of got this ability to have this shared experience. Tranquility module, that's 138.8 degrees. Yeah. The service module here. That's producing a little bit of oxygen. So we've kind of got this. We can have this shared experience. We can all visualize what's happening on the ISS, similar to we had with that 3D scene, but instead we are getting it through a shared experience. And what doesn't show on the the screen, but what I get to see, if I look down, I see the world. So I can even see where the ISS is at the time over a 3D model of the globe. But for some reason, that doesn't come through on the screen share. So that's the industrial metaverse. Well, that's how we've got all this data. We've got IoT sensors on the International Space Station. We're feeding that data down to digital twins so we can visualize that data. We're putting it into a 3D scene so we can have that experience on a 2D version where we can see all the data in live dashboards because it's such a huge amount of data. And then we can collaborate on this in the industrial metaverse. We've got this ability to very quickly ask questions of data, get answers, because we are visualizing a huge amount of data using the power of the advances in technology we've made in the information age. So you want to build this yourself, which leads into the question from Claudia, which is able to access the examples provided here. So I can't give you access to the exact examples that are running. These are running internally at Microsoft, but you can build all these things yourself. So we've got links for the tools that you can use to build this stuff yourself. If you want to get started with augmented reality, aka.ms/LGPC-XR. That's a show I did with Gustavo Cordado, who's built XR for Beginners, a curriculum to teach you the principles of extended reality, and includes showing you how to build a basketball game that you can use on your phone to shoot virtual hoops. So there's a video where I go through it with Gustavo, and that's got links to the actual curriculums, all free, so you can learn to build extended reality stuff. And then if you actually want to recreate what I've done here with the ISS, aka.ms/ISS-metaverse. We introduced some of these things just before Microsoft Ignite, our big tech conference last year. So back in June, I caught up with Alex and Riley, who are involved in our IoT metaverse teams. And they're the folks who actually put together this particular demo. So we talked through this demo on this, and there's links there to actually deploying this yourself. It uses up a fair amount of Azure credit because of all the data we've got flowing around, but you can build this yourself and actually deploy this yourself if you've got your own HoloLens. So yeah, thank you very much for sharing those links in the chat. So we go back to our original question. What do these two have in common? And the answer is they visualize data. For millennia, we've been gathering data and working out how to visualize it. Now, as we've got more data, we needed more advanced techniques to visualize it. We've been able to see how much beer has been sold, right up to why is a cholera outbreak happening, just because we can visualize this data. We hit the information age, explosion of data, exponential quantities of data. We need better tools, live charts. Seeing this data live was the biggest tools we had in the information age, not just relying on a chart that takes a year to produce. Dashboards bring this together, so we have visualizations of multiple data points together, allowing us to ask better questions. And on IoT, exponential growth of data, we needed better tooling. And so that's where we started thinking about digital twins to bring that data into real world representations, and then visualizing that through 3D visualizations with added on data, and then bringing that to the industrial metaverse so we can collaborate on everything together. So these two objects, they're basically the same. They're just separated by 6,000 years and 6,000 years of technology. And so I just want to wrap up by leaving you with a question. Something I want you to just to think about, as you go about the rest of your day. We've seen the whole movement from Sumerian clay tablets with sexagesimal numbers for tracking beer, right up to the ISS and the HoloLens. What's next? What do you think is going to happen next around data visualization? What is the next stage in this evolution of gathering data and making decisions on data? So something for you to noodle on. And so with that, thank you very much for your time. And if you have any questions, check them in the chat. Otherwise, get a hold of me, linktr.ee/JimBobBennett. It's got links to my Twitter, Mastodon, LinkedIn, GitHub. Feel free to reach out there with any questions. Otherwise, thank you very much for your time.
Thanks, Jim.
Thank you. Thank you very much. That was really interesting. History of data visualization from the beginning.
Yep, glad you enjoyed it.
Really cool. I was wondering how long did it take you to build that digital twin of the ISS?
I didn't build it, so Alex built it. The link I mentioned, the one you dropped to the chat, aka.ms/ISS-metaverse. So it was Alex. He actually put that together. It took him a fair amount of time to build this. Part of his role is to create these kind of cool demos. So he did all the hard work. My background is IoT, so I could gather the data, I could build the things, but I struggle when trying to create things for the HoloLens. I'm not very good at building these apps yet. It's not my area. Alex created all this. So big shout out to him for the hard work he did.
Very cool.
Together.
I really liked the demo you showed where the people like walking along all those machines and just seeing the data float above the machine, because my company built something like this a while ago for cows, where you're like you walk through a farm and you see like all your cows, and then you just see all the data above the cows. But that was before digital twins were published by Microsoft. So now it's way less work. So that's awesome.
Yeah, you gather data from the cow, like because there's so much health data you can get from cows. So we'll get
exactly.
These smart you fit on the ears, don't you?
There's huge amounts of data on the cows. Yeah, they track everything. Yeah.
So if you're gathering that, and then you can very quickly look across your herd, is there a cow that's temperature's too high, or the noises they're making could be tied to a certain illness that they've got, and the fact you can just literally just look across your herd and see this. Yeah. A cow is sick. Well, which one? Okay, it's that one over there.
Exactly. And which cow is that? Oh, and where do I find it? Oh, over there.
Mm-hmm. Yeah. Incredibly powerful. And things, you show these pictures and people think this is science fiction. Yeah, this is not what we have today, but no, it is. It is. All the tools to build this are there today. It's just so far it's only the larger companies that have invested the time into doing it. We did a demo at Microsoft Ignite, our big conference recently, for one of the Coca-Cola bottling plants. They have billions to spend on these kind of investments. But the technology is getting easier and easier and easier. Just the add-on of 3D Scene Studio. If you want to build a 3D scene, you literally can import a model and then very quickly attach things to it. So that ISS is an open source model. I think it's from NASA themselves. You drag that into 3D scenes. This part of it, I want to tie it to this bit of data. It's almost like no code. Click, click, click. And you've got this. When this number goes over here, color it orange. When it goes above this, color it green. You've kind of got this ability for business people to build the 3D scenes through no code. And so the amount of work you have to do to create it is getting less and less and less. So it's really exciting.
Maybe the complexity is not in how to get the data, but more like where to put it and how to visualize it, right? If you have those huge amounts of data.
Yeah, I think with a lot of companies, and I find the same question for, it doesn't have to be an enterprise company, even with small companies. It is often, they find it very difficult to understand how to bring everything together. And I think that's the journey we need to go into. And they will need to find out what brings them value with the data they're collecting, and what can they reuse to actually improve their business, and what would be the direction to go, visualization. Because the cool thing is, and the one you explained with the cows, I love that one. I've seen that one.
You can see it in Amsterdam.
All these examples show that digital twins is not only about showing a manufacturing line or an oil plant. It could even be the process of documents flowing through different backend systems and understanding what's happening. It's purely for giving you those insights, and then think about how you display that to your end users.
One thing I often say whenever I talk about IoT is that an IoT engineer's best friends are a data scientist and a business expert. Because there's no point in me gathering data from my IoT devices if you don't know what to do with it. Yes. So I need to gather the right data for you so that you can do the things you need to do. And to do that, I need somebody who can understand the data and somebody who understands the business who can come together and tell me what to collect. So, but interesting, your point about digital twins is not just for industry. I mean, as you say, hospitals could use it for tracking patient flow. Very quickly look at a hospital and see how many people are coming in through emergency, how many people are coming in through here. When there's something like COVID, we have to have a lot more restrictions. How are we managing those restrictions? So just that flow of people, you could build a digital twin using cameras and other tracking for individuals and just follow those people around. So there's so many opportunities that you can do with it. If you've done the cow, if you've ever done a video on the cow one, I'd love to see that, because I've chatted to a few folks who've built digital agriculture solutions. So if you've done a session on the cow one, please share it. I'd love to see that.
I'll share it. Yeah, it's actually at the Microsoft office in Amsterdam. You can see it. There's a live demo of it, I think.
I need to go to Amsterdam at some point then.
Yeah, they have something called the Holo Suite, which is a 360 room where you can have experiences around business cases where they combine all the different services. This is one of them.
Nice. I need to check that out next time in Amsterdam.
So there are not many questions further, and you actually did a great job on answering them through your session. So thank you very much for that. If there are no other questions, I will make sure that the links are in the chat. I will also add the links to the description of the YouTube final recording when it's up. So even people can find it in the description to know where to go to for this. So thanks again, Jim, for the perfect session.
Thank you so much. Yeah, it's really interesting. I have one last question. Do you have like a favorite, like through all the history of data visualization, do you have a favorite visualization? I think you talked about the pump. Is that it? Or is there one that you like even more?
It's the pump. I mean, I've always been fascinated by maps. I've never kind of dived too far into fascination, but every time I do anything with maps, they always find them so interesting. But yeah, John Snow's work with the Broad Street pump, that's probably my favorite. The fact that he was able to really pinpoint quite accurately just there on the street map. In fact, if I can bring it back up again. I don't know if I can get my thing to work. I don't know if I can get the screen shared. I'll try and bring it back up again. Yeah, the fact that you've got the streets here, and he was able to pinpoint quite accurately where everything was happening, and it's quite obvious when you look at this. It's all centered around one point. It could almost literally just move a circle around until you find the central point, and that central point is Broad Street, and the pump is literally right here in the middle. And so just very quickly going, okay, I think it's water. I've established that based off the different water coming in to different parts of London lead to different outbreaks, must be the water. And then I come here and I just plot this, and it's so obvious that this is the place it comes from. I love the story, and I just think it's a really great use of maps in visualization. So this is probably my favorite visualization story.
Awesome, thank you.
Cool, thank you very much. It's been a lot of fun.
Yeah,
Okay.
it has been. I really enjoyed your talk. Okay, well, thank you so much. I would say let's wrap it up then. Thank you so much, Jim.
So we're at the end of a very interesting session at globalxr Talks. I love both, actually. One more on the business sales side, one on the more technical and more in-depth. Learned a lot about the second session, actually. Didn't know about those maps and the way of how you actually, where it comes from. So really interesting.
Yeah, and for me it was the other way around. Like I learned a lot in the first talk.
Yeah, I'm a bit more on the other business sales side, so apologies for that. But that's not a problem. So we want to thank everyone who has been watching the session, and we will have a next globalxr Talks happening on
April 20.
Thank you, on April 20. And we're even working, but that would be more for the Netherlands, on a live event, but that will be separately mentioned on the meetup. So thanks again, everyone, for watching, and hope you have a great day or evening.
Thank you, and see you next time, hopefully.